A very good morning to one and all. So myself, Avinash Jail, Assistant Professor, Department of Electronics and Communication Engineering, SVC Bengaluru. So today we will discuss about VLSI design module number 1 of your VTU subject. So when you are coming for the syllabus content, in this particular module, we are going to discuss about the history, mass transistors, CMOS logic, the introduction for the MOS transistor theory, the long channel IV characteristics, non-ideal effects, and DC characteristics. So when we are talking about the history of the VLSI, okay, how it is been evolved is very simple. So here the improvements in the integrated circuits have enabled the space for the exploration and made automobiles safer and more fuel efficient. So revolutioned the nature of warfare. So this particular concept brought much of the mankind's knowledge to our web browsers and made the world a flatter place. So you can see that when the initial days, if you take how that particular, what is the size of the automobiles, what is the size of the electronic gadgets. So all these things are taking enormous size. But today, if you see, those have become flat. And everything, every knowledge is been incorporated in the web browsers only. So coming back to the introduction. So the figure 1.1, which we are going to see next, shows annual sales in the worldwide semiconductor market. The integrated circuits become a 100 billion per year, $100 billion per year business in 1994. Just imagine. So in 2007, the industry manufactured approximately 6 quintillion. Okay, it's 6 quintillion transistors, nearly a billion for every human being on the planet. That means what? For one person, if you take 1 billion transistors are available, that is the ratio they have made. So that means for that much enormous growth has been occurred in the semiconductor theory. Thousands of years have made their fortunes in the field. New fortunes lie ahead of those who involve ideas and the talent to bring these ideas into the reality. So we were not aware of it. So when the person is having an idea that everything should be available in the gadget, so that idea, he made it, he invented it, he innovated the concepts, and he made that particular ideas comes into the reality. So for this, all these things, VLSI technology is a very, very boon. Okay, so in this particular figure 1.1, we can observe very clearly. So in 1982, okay, so in the x-axis, we have taken the year. So in the y-axis, it is the global semiconductor billings. So here in terms of billion of US dollar, so how much billing, that means what, how much amount is been invested for this particular semiconductor. So when you're talking about in the year 1982, it's a very, very less. It is less than 50, approximately 25. Okay, so 1982 it is nothing. 1984 it is $25 billion. So 1986 also same thing. 1988 it is gradually started to increase. But when you see in the period of 1994, so it has almost reaching to the $150 billion. After that, for another 4 years, it was a saturated period, and once again it got somewhat higher. In the 2000 year, 2000, it is 200 billion. It has touched $200 billion. So after that, once again, it has come down on the graph. But when you see this particular graph is okay, so even though for 1 or 2 years it is decreasing and all, but the end to end, if you say, okay, so it is something like a linearly, it is going to be increasing. The year 2008, so it has already crossed 250 million. Okay, so $250 billion for the global semiconductor industry. So that means what? That much necessity and that much demand and that much usage of semiconductor has been happened. So it is, we have taken the graph up to only 2008. If we are now, we are in already in 2021. So just imagine for another 10 years how much it might have gone up. So that is a necessity. Okay, and that is the future. So during the first half of the 20th century, the electronic circuits used large, expensive, power-hungry, and unreliable vacuum tubes. But in 1947, John Bardeen and Walter Brattain built the first functioning point contact transistor at Bell Laboratories. So in the 1947, at the Bell Laboratories, they have made the first functioning. See, concept is separate, but making the real thing is different. So it was nearly classified as a military secret, but Bell Labs publicly introduced the device to the following in the following next year. So 10 years later, the Jack Kilby at Texas Instruments recognized the potential for miniaturization if multiple transistors could be built on one piece of silicon. So here you just understand. So the miniaturization is a very, very important concept. Okay, so miniaturization is a fundamental important concept led many things to happen in the world. That means what? On the single piece of silicon, if we are able to make multiple transistors, okay, so then you are in a good thing. So now we can see that a small chip can be having the 32 GB, 64 GB, 128 GB of storage capacity. Okay, so that particular transistor when we are talking about, okay, so what do you mean by transistor? Okay, so we have called it as a transistor because it is a resistor or a semiconductor device which can amplify the electrical signal as they are transferred through it from one input to the output terminals. So it is, if you will, the electrical equipment of vacuum tube amplifier. Okay, but there the similarity ceases. It has no vacuum, no filament, no glass tube. It is composed of entirely of cold solid substances. So that is what exactly a transistor. So it will pass the electrical signal through it from the input to the output terminal, but it has no vacuum, no filament, no glass tube. So it is purely made up of a semiconductor. Is it clear? That is what exactly the meaning of transistor. The first the concept of miniaturization in the figure 1.2b shows the first prototype of an integrated circuit. Prototype of an integrated circuit constructed from a germanium slice and gold wires. So that was costly, very costly, but still they have made it. Figure 1.2b, you can see it. In the first transistor, in the left hand side, the figure A is, you can see that the first transistor, you just see that for one transistor, how much the setup has been made. Okay, so in the figure B, you can see that the first integrated circuit, that means what? Two transistors, three transistors have been connected together. Okay, and then it has been made, that is called as what? First integrated circuit. So today in that particular space, you can do the wonders now. So it is more than, okay, 2 times of your mobile size. So this particular diagrams we have taken with the permission of the laboratories which have developed this particular prototypes. So the figure B, especially from the Texas Instruments. So transistor can be viewed as electrically controlled switches with a control terminals and two other terminals that are connected or disconnected depending on the voltage or current applied to the control. So soon after inventing the point contact transistor, Bell Labs developed the bipolar junction transistor, that is BJT, what we say today. So bipolar transistors were more reliable, less noisy, and more power efficient. Early integrated circuits primarily used bipolar transistors. So when the transistor is invented, after that they developed the BJT. So they found that BJT is more reliable, they are less noisy, and more power efficient. So depending on this particular advantage, they understood that early integrated circuits primarily used for bipolar transistors. But next, what happened? The bipolar transistors require a small current into control base terminal to switch much larger currents between the other two terminals. The quiescent power dissipated by these base current drawn even when the circuit is not switching. So those are one of the disadvantage in the BJT. Okay, so the next video we'll discuss about the invention of the transistor. Thank you for listening.